This is a lesson on indices or powers. In this lesson, we will learn to simplify expressions with powers, evaluate numerical expressions with powers, solve equations with powers, and do calculations in standard form. We begin by taking a look at an index form. The index form 2 to the power of 3 has a base of 2 and an index of 3 or a power of 3. Base 2, index 3, and 2 to the power of 3 means 2 times 2 times 2, or simply 3 factors of base 2. Thus, 5ab to the power of 4 is simply 5ab times 5ab times 5ab times 5ab, and a plus b to the power of 2 is simply a plus b times a plus b. Next, we take a look at the laws of indices. In the first example, we have the multiplication rule. When we multiply index form of the same base, we can add the power. Similarly, multiplying index form of base 3, we have 3 to the power of m plus 2. And when the base is x plus 1, we have x plus 1 to the power of 3 plus 4. As for the division rule, again we need the same base. We can subtract the power. When the index form is in a fraction form, we take the power in the numerator, subtract away the power in the denominator, giving us b to the power of 2. The result can also be thought of as cancelling b to the power of 4, giving us b to the power of 2. For the power rule, the power outside the brackets must be applied to every term within the brackets, and we take the inner power multiplied by the outer power. Thus, we have 2 to the power of 3, a to the power of 6, b to the power of 3 over 5 to the power of 3, c to the power of 9. The reverse of the laws is also true. When we multiply index with the same base, we add the power. Similarly, we see the addition of powers can be written as multiplication of two similar bases, 3 to the power of m times 3 to the power of 2. And similarly, here we have a plus b to the power of n times a plus b to the power of 3. And we also see subtraction as division of the same base, 5 to the power of m divided by 5 to the power of 3. And here we have 3 to the power of a divided by 3 to the power of b. Now, when we have a common power throughout, we can take the power outside the brackets, giving us ab over c to the power of 2. And 7 to the power of 2m can be interpreted as 7 square to the power of m, or 7 to the power of m to the power of 2. Next, we will see how we use the laws to simplify expressions. In the first example, when we open the brackets, we have 3 square m square n4 multiplied by 2 cube m6 n3. This is 9 times 8 is 72. And the common basis, m square times m6 is m to the power of 8. The basis n4 and n3 is n to the power of 7. In the second example, we first open the brackets to give us 2 square a to the power 4 b to the power 4 over 6 a square b cube. 4 can cancel with 6 to give us 2/3. And here a4 cancel with a square will give us a square in the numerator. And b4 cancel with b cube will give us b in the numerator. In the next example, we first cancel the 4 and 6 to give us 2/3. And then we cancel a cube and a to give us a square. A plus b to the power of 5 cancel with a plus b to the power of 2, giving us a plus b to the power of 3. And in the last example, we cancel 5 and 20 to give us 3/4. And here we have a to the power of m plus 5, which can be written as a to the power m plus 2 times a to the power of 3. In this way, we can cancel a to the power of 3. Thus, we have 3a to the power of m plus 2 over 4. b square cancel with b to the power of 4 is b square in the denominator. Next, we take a look at the different types of indices. The first is a zero index, and anything to the power of 0 is 1, except 0 to the power of 0, which is undefined. Thus, for the first sum, we have equals to 1, equals to 1, equals to 1, equals to 1. A negative index is interpreted as 1 over a square. And if we have negative indices in the numerator as well as the denominator, we can convert the positive index by changing the numerator with the denominator. Thus, 2 to the power of negative 3 is simply 1 over 2 to the power of 3, which is 1/8. In this example, notice that the negative power is only for b. Thus, 2a has no change, and b to the power of negative 3 is moved to the denominator to convert to positive power. In this case here, we can convert to positive power by inverting the fraction 5 over 3. Next, we look at fractional or decimal index. In the fractional index, the numerator belongs to a to give us a square, and the denominator is the root. Thus, the denominator here is 3. We have cube root of 8. In the second example, we have a decimal index which can be converted to a fraction, 1/5. Thus, this is simply the 5th root of 32. And for the negative index here, we have 1 over AB to the power of 1/4. And 1/4 is simply the 4th root of AB. In the last example, we have the 4th root of 5A to the power of 3. The root form is also called a radical form. Next, we take a look at evaluating numerical index form. In the first example, notice that all the powers are the same. Thus, we can bring the common power out. Thus, simplifying the expression. The numbers cancel to 2. In the second example, we have a fractional index. First, note that the denominator is 4. Thus, we can express 16 as a power of 4. In this way, we can cancel the power with the denominator, giving us 2 to the power of negative 3, which is 1 over 2 to the power of 3, which gives us 1/8. In this example, we have different bases. We need to change it to the same base before we can solve it. Thus, we rewrite 4 as 2 squared to the power of 3 times 3 squared to the power of 2 over 2 times 3, which is 6 to the power of 4. Now you can see that we have base 2s and 3s. Next, we apply the power rule. We can cancel away 3 to the power of 4, and 2 to the power of 6 divided by 2 to the power of 4. We cancel 2 to the power of 4 to give us 2 to the power of 2, and the answer is 4. In the next example, remember that if we have a negative power of a fractional form, we can invert it to convert to positive power. As for division, we can change to multiplication and invert the fraction after it. Now we can apply the power in the brackets. 2 to the power of 3 over 3 to the power of 3, which is 8 over 27, multiplied by 27 over 8, giving us 1. From a difficult expression, we simplify it to a simple expression 1. Next, we take a look at equations in indices. There are 3 types of equations in indices: unknown power, unknown base, and fractional power. For unknown power, we need to make the same base. Once the bases are the same, we can equate the power, thereby solving the sum. In the second example, we do not have a common base. Thus, we have to express them all to base 5, that is 5 to the power of 2, which is 25, divided by 5 to the power of x plus 1 equals to 5 to the power of 3. Applying the law on division, we have 5 to the power of 2x minus x plus 1. Thus we have 5 to the power of x minus 1 equals to 5 to the power of 3. So once the bases are the same, we can equate the numerator, giving us x equals to 4. In the next example, we have 2 to the power of x plus 3 equals to half. We can write half as 2 to the power of negative 1. Thus, we have a common base of 2. We can now equate the power, and the answer is negative 4. In this example, remember that 1 can be expressed to any base. In this case, we need it to be base 3. So 1 is expressed as 3 to the power of 0. And now the base is the same. We equate the power, giving us m equals to 2. In the next example, we do not know the base. And if we have a common power, we can equate the bases, giving us the answer. Thus, when we do not know the base, we must make a common power. In this case here, this is 1 over 32, which can be expressed as half to the power of 5. And once the powers are the same, we can equate the bases, giving us the answer. Similarly here, we have x minus 2 to the power of 3, and express this to the same power, we have 4 to the power of 3. When the powers are the same, we can equate the bases, thereby solving the sum. For the case of the fractional power, we need to reduce the power to 1. We can do this by applying the reciprocal power. In this case, the reciprocal of 1/3 is 3. Applying to both sides, we have x to the power of 1 equals to 5 to the power of 3. X to the power of 1 is just x. In the second case, we have a negative fractional power. Thus, we have to apply a negative reciprocal 3 over 2 to both sides of the equation. The power on the left has become 1. And on this side, we have 4, which can be expressed as 2 squared, so that the denominator can be cancelled out, giving us 2 to the power negative 3, which is 1 over 2 cubed, which is 8. And in the last example, again we apply the reciprocal power. In this case is 5 over 3 to both sides. Again, the power on the left is 1, and on this side we have 2 cubed to the power of 5 over 3, so that 3 can be cancelled out. giving us 2 to the power of 5, which is 32, and therefore the answer is 30. Next, we will take a look at how we use indices in standard form. Very large numbers and very small numbers are written in standard form, such as 3,250,000 can be written as 3.25 times 10 to the power of 6, and 0.0000136 can be expressed as 1.36 times 10 to the power of negative 5. And in next form, a standard form, we must take note that the number here must be less than 10 and it cannot be less than 1 times a power of 10. Let us try to convert these numbers to standard form. There are 5 numbers here. We put the decimal point after the first non-zero digit to give us 4.126 multiplied by 10 to the power of the number of places after the decimal point, 1, 2, 3, 4. For a small number, we put the decimal point after the first non-zero to give us 2.13 multiplied by 10 to the power of, there are 4 zeros in front, so we have negative 4. Small numbers have negative powers of 10. Let us now take a look at multiplication of standard form. When we multiply standard form, we group the numbers together and the powers of 10 together. We multiply the numbers 3.2 times 1.5 to give us an answer, multiplied by 10 to the power of 3. In the same way, for division, again, we first write it as a fraction form so that the numbers will be together and the powers of 10 will be together. Dividing the numbers, we have 0.8 times 10 to the power of, applying the law of indices, 10 to the power of negative 2 minus 5. That is minus 7. The answer is still not a standard form as this is less than 1. Thus, we have to rewrite this as 8 times 10 to the power of negative 1 because of 1 0 in front times 10 to the power of negative 7. Thus, the answer is 8 times 10 to the power of negative 8. We look at further examples of standard form. Let us now take a look at the power of a standard form. Applying the law of indices, we apply the power to 5 as well as 10, giving us 25 times 10 to the power of 6, which is just 2.5 times 10 to the power of 7. Since 25 has a 10, we add it 1 10 to the power here to give us 10 to the power of 7. If we have a multiple in front, we must first take care of the brackets. 3 square times 10 to the power of negative 10. Next, we just simply multiply 4 times 9, giving us 36 times 10 to the power of negative 10. And since 36 has 1 10, we have to add 1, giving us 3.6 times 10 to the power of negative 9. We now take a look at reciprocal. A reciprocal can be written as separate fractions, 1/4 times 1 over 10 to the power of 3. And 1/4 is 0.25 times 10 to the power of negative 3. There's 1 0 in front, so that is a negative power of 1. Thus, this becomes negative 4. If there is another number other than 1, we still do it in the same way by splitting it as 3/5 times 1 over 10 to the power of negative 2. And 3/5 is simply 0.6 times 10 to the power of 2. Remember that negative index below is moved up to become 10 to the power of 2. And this is 6 times 10 to the power of 0.6 has a 0 in front. There's a negative 1. Thus we have 10 to the power of 1. In subtraction, we need to have a common power of 10, which we can factorize out to give us times 10 to the power of 4. 8.2 minus 5 is 3.2 times 10 to the power of 4. In this case here, we have different powers of 10. We need to make a common power of 10. Thus, we can write 10 to the power of 6 as 10 to the power of 2 times 10 to the power of 4. Thus, we have a common power of 10. And now we have 3.2 plus 500 times 10 to the power of 4. This gives us 503.2 times 10 to the power of 4. 500 has a power of 2. Thus, we have 5.032 times 10 to the power of 2 times 10 to the power of 4, giving us 5.032 times 10 to the power of 6. This ends the lesson on indices. Thank you.